Yo, Wagwan. Yeah, man. I'm Mr. Garfield here. We're going to be looking at a CAPE integrated mathematics question in Module 1, that's Foundations of Mathematics. And we're looking at how to solve systems of equations using Cramer's rule. All right. So part 1 says we are to express the following systems of equations below in the form AX is equal to B. All right, so they gave us the equations there. And part 2 says, show that y is equal to -2 by the use of Cramer's rule or otherwise. Let's do part 1. All right, let's do part 1. So this is going to be part 1 solution. They gave us 2x plus y minus z is equal to -3 and 3x minus 2y minus z is equal to 4. And they also gave us that x, all right, x plus 2z is equal to 7. Okay, and they want us to write it in the form of ax is equal to b. And by the way, ax and b are matrices, okay? So we need to find those matrices. So the matrix A, which we normally call the coefficient matrix, all right, is going to be the coefficients of the variables x, y, and z in each equation, all right? So let's say the first column here represents the coefficients for the x variable, and let's say the second column represents the coefficients for the y variable, and let's say the third column represents the coefficients for the z variable. Okay, let's look at it. The coefficient for x in the first equation is 2. When I say coefficient, I just simply mean the number in front of the variable. Okay? So 2 and the coefficient in front of x here, the coefficient of x here for 3x, that's 3. What is the coefficient for x? Now, this can be written as 1x. All right? 1x. So it means that the coefficient there is 1. So the first column, I will have 2, 3, and 1. All right, let's look at the coefficients for the y terms. Okay, so I have y, which can be written as 1y. All right, so it means that 1 is going to be my coefficient for the y term. Okay, and the coefficient for the y term here in the second equation is -2. Okay, but what about the third equation? What is the coefficient for y? So I know that I'm going to have the 1 and the -2, but what is the third element here in the first column? So I can rewrite this equation as 1x plus 0y plus 2z equals 7, right? Because I know that 0 times y is 0. So it means that 0 is going to be my coefficient for y. So once you don't see the term here that you're looking for, it means that the coefficient of that variable is going to be 0. All right, so let's look at the coefficients for the z now. So in the first equation, I have -z, which can be written as -1z. I have -1z again in the second equation. All right, so it means that my coefficients are -1, -1, and +2. Okay, so -1, -1, and +2. Good. That is what we will have. Okay, so we're finished with the matrix A. That's the coefficient matrix. Let's find the matrix X. Now the matrix X is going to be a column matrix, okay? A column matrix simply means that we're going to have only one column. All right? only one column. So the matrix X is going to be comprised of the variables that we're trying to find, right? So we're given a system of equations in X, Y, and Z. So it means that the matrix X is going to be X, Y, and Z, right? If we were given this system of equation in P, Q, and R, then it means that the matrix X will be P, Q, R. Okay, so I hope that is clear. Now the matrix B is going to be equal to, it is also going to be a column matrix, okay, only one column, and it is going to be comprised of the numbers here to the right-hand side of the equations. Okay, so it means that matrix B is going to be equal to -3, 4, 7. All right, that is what we will have. Good. So remember that they told us that they want it in the form of AX is equal to B. So I'm going to write it in that form now. So I can now say that AX equals B implies the matrix A we know is 2, 3, 1, 1, -2, 0, -1, -1, 2. All right, that is the matrix A. And we're multiplying it by the matrix X, which is going to be X, Y, Z, and that is going to be equal to the matrix B, which is -3, 4, 7. Okay, good. So that is what we will have. All right, so we're now finished with part 1 of the question. So part 1 gone. Part 2 now says we are to show that y is equal to -2 by the use of Cramer's rule or otherwise. All right. Now, when you're solving a system of equations like this, you can use Cramer's rule. You can use ERO, which is an alternative method. That's the elementary row operations. All right. Now, CXC says that they wanted to use Cramer's rule. However, they accept any other methods that you were taught. Okay. I will be using Cramer's rule because Cramer's rule is a much simpler approach. Okay. Good. That is what we have. So let us write the solution now. So part 2, solution. All right. Now, anytime that you're going to use Cramer's rule, it means that we're going to have to find the determinant of the coefficient matrix. Okay? Meaning I'm going to find the determinant of the matrix A. All right? So let us look at it. We know that that is the matrix A here. So we're going to find the determinant of that matrix. I'm going to use a simple approach, which is using Saros rule. All right, so I'm using Saros rule to find the determinant of the matrix A. So when we use Saros rule, this is what we're going to do. We're going to write the first 3 columns of the matrix. So column 1, that is going to be 2, 3, 1. Then we're going to write column 2, which is going to be 1, -2, 0. Then we're going to have column 3. All right, column 3, which is going to be -1, -1, and a +2. All right, that is what we have. Then we're going to repeat the first and second columns of the matrix A. Okay, so in other words, I'm going to have column 1 again. So column 1 we know is 2, 3, 1, and then column 2. All right, column 2 is 1, -2, 0. Good. That is what I have. Those are the columns. So we're now, remember that we're trying to find the determinant of the matrix A. All right. So this is what I'm going to do now using Saros rule. I am going to find the product of the diagonals. All right. So the first diagonal is going to be 2, -2, 2, right? 2, negative 2, 2. So that's, we're going to multiply those elements together. So that's 2, negative 2, positive 2, plus the other diagonal is going to be 1, negative 1, and positive 1, right? So it means that I will now have 1 times negative 1 times a positive 1 plus, there's one more diagonal remaining, which is the negative 1 times 3 times the 0. All right, so negative 1, 3, and 0 are the elements in that diagonal. So we're multiplying them now. So that's negative 1 times 3 times 0. Okay, minus, all right, minus, we're gonna have other diagonals as well. All right, we're gonna have other diagonals as well. So this is the diagonal 1, negative 2, and negative 1. All right, that's my first diagonal there. So that's gonna be 1 multiplied by negative 2 multiplied by negative 1 plus the other diagonal is going to be what? That's going to be 0, negative 1, and positive 2. Okay, so that's 0 times negative 1 times 2 plus the other diagonal. This is the last one now. That's 2, 3. All right, that's 2, 3, and 1. So we're gonna have 2 times 3 times 1. Okay, so that value, right, this value will be my determinant. Good. Let us now simplify. So the determinant of A is equal to 2 times negative 2 times 2. That's going to give me a negative 8. 1 times negative 1 times 1. That's going to give me a negative 1. And negative 1 times 3 times 0 will give me 0. Minus 1 times negative 2 times negative 1 will give me a plus 2. Plus 0 times negative 1 times 2 will give me 0. Okay. Plus 2 times 3 times 1 will give me a 6. Okay. So let's simplify now. So this is equal to negative 8 minus 1. I'm going to distribute the negative inside the brackets. Okay. So when you do that, each term inside the bracket will be affected. So negative 1 times 2, that's negative 2. Negative 1 times 6, that will give me a negative 6. All right, remember we don't have to write the 0. Okay, so this is going to be the determinant of A. So if you put that value into the calculator, you will get a negative 17. All right, good. So we have finished finding the determinant of A. Now let's go back to the question. Remember, the question stated that we are to show that y is equal to negative 2. Okay? Now, since I want the value for y, I'm going to find the matrix AY. All right? So I now want the matrix AY. Okay. So what will happen is that the column for the x variables will remain the same. That's 2, 3, 1. The column for the z variables will remain the same. That's negative 1, negative 1, and positive 2. Now, because I want the value for y, the values in the y column, which is the second column, is going to change. Okay? So I'm going to delete the numbers in the y column here, and I'm going to put these values instead, the elements of matrix B. Okay? So it means that my matrix AY is going to be equal to, in the second column, we're going to have -3, 4, 7. All right, that is the matrix A, Y. The Y is supposed to be a subscript, by the way. Okay, the Y is supposed to be a subscript there. Good. All right. Now that I have the matrix AY, I now need to find the determinant of this matrix as well. So I'm going to be using Saros rule once more. Okay, so let us do Saros rule. So using Saros rule, so we're going to write down the first, second, and third columns of the matrix. So column 1 has 2, 3, 1. Column 2, that's going to be -3, 4, 7. Column 3, that is going to be -1, -1, +2. And remember now that we also need to repeat the first and second columns of the matrix. So column 1 is 2, 3, 1. All right, and column 2 is going to be -3, 4, 7. Okay, so I now want the determinant of the matrix AY. All right, so this is going to be equal to what? So we're going to find the product of the diagonals. So the first diagonal is 2, 4, 2. All right, those are the elements that we're going to multiply together. So that's 2 times 4 times 2 plus the other diagonal now is going to be -3, the -1 here, and +1. All right, so that's -3 times -1 times +1 plus the last diagonal here is -1, 3, and 7. All right, -1, let's write that down. -1 times 3 times 7 minus the product of the other diagonals, which is going to be, the first diagonal here now is 1, 4, -1. All right, those are the elements. So 1 times 4 times -1 plus, all right, what is the other diagonal? So the other diagonal here is 7, -1, and +2. All right, so 7, let's write that down. 7 times -1 times 2. Okay, plus there's one more diagonal. All right, so that is going to be 2, 3, -3. Good. So I'm going to multiply those elements together. Okay, so that's 2 times 3 times -3. All right, so we're just required to simplify this now. All right, this will be our answer for the determinant of AY. So 2 times 4 times 2, all right, that will give us 16. -3 times -1 times +1 will give us a +3. -1 times 3 times 7 will give us a -21 minus 1 times 4 times -1 will give me a -4. All right, and then 7 multiplied by -1, all right, times 2 will give me what? That will give me a -14. right? And then 2 times 3 times negative 3, that will give me negative 18. Okay, good. That is what we have. All right, good. So let us now simplify this now. So this is now going to be equal to 16 plus 3 minus 21. I'm going to now distribute the negative sign inside the brackets. So each term will be affected. So negative 1 times a negative 4, that's a positive 4. Negative 1 times a negative 14, that's a plus 14. Negative 1 times negative 18, that's plus 18. And this is going to be equal to, so we have determinant of the matrix AY. If you put this value into your calculator, you should get a value of 34. All right, good. So now that we have the value for the determinant of AY, and we have the determinant of the matrix AY, sorry, and we have the determinant of the matrix A, Cramer's rule says if I want to find the value of Y, that is going to be equal to the determinant of the matrix AY, okay? And I'm going to divide that by the determinant of A, okay? So Y is equal to the determinant of AY, we just calculated is 34, all right? And we are going to divide that by the determinant of A, all right? The determinant of A. Now remember, we calculated the determinant of A as negative 17, all right? So I'm going to put the 17 here. Now, in mathematics, we don't like to leave negatives in our denominator, so you can either choose to put it in the numerator or to the side. I am going to put it to the side. All right, so y is now going to be equal to negative 34 divided by 17. If you put that in your calculator, you should get a value of negative 2. All right, now remember in the question, it said that we are to show that y is equal to negative 2. Okay, so it means that I have shown it, right? So I can now come down here and say shown. All right, shown.